All right, okay, good. Let's start having a look through these then. So I have given you two binomials which I have asked you to expand, okay? Now the first one, so 6 plus x to the power of 4, is just like what we were looking at the start of the last lesson, okay? So this is fairly straightforward, okay? So how are we going to expand this out? Okay, good. So you take x and you take, 6 to the power of 4. Yeah, you can start there. Okay, plus. Yeah, good. So the next coefficient is 4. By the way, how did we get that coefficient there? Sorry? Yeah, absolutely. So you can think about it in terms of the choose function. So that would be, 1 goes there, doesn't it? But that's 4 choose 0. Okay, if you like, you take this power, you're choosing 0. That one's going to be 4 choose 1. Okay. What's the next thing that goes there? So you've got 4. Finish the term for me. Good. 6 to the power of 3. Just x. Good. So you notice that you're climbing down in the powers of 6 and climbing up in the powers of x. Okay. What's the next coefficient going to be? Good. 6, which again comes from taking 4 and choose 2. Good. All right, good. Finish this term for me then. Good. Well done. So again, we're climbing down in the 6's and climbing up in the x's. Next term. Yep. Good. And then finally, good. Okay. And you notice that this coefficient, this 4 here, corresponds to 4 choose 3. And this coefficient, this 1 here, corresponds to 4 choose 4. Does that make sense? Yeah, that's all fairly familiar. So you notice the powers of 6, so I start with 6, and I climb down in the powers of 6, so I start at 6 to the power of 4 because there's a 4 there, and I climb down in the powers of 6, and the x, I start at x to the power of 0, but of course just 1, so don't bother writing it, and then we just climb up in the powers of x until we get x to the power of 4. Okay, so that's all fairly straightforward. Okay, has anybody actually tidied this up? So for example, what is 6 to the power of 4? 1296. Okay, plus, so 4 times 6 cubed is, sorry?
864.
864 times x, plus 6 times 6 squared, so that's 216?
Yeah.
Yep. 216x squared, plus 4 times 6 is 24. X to the power 3, plus x to the power 4. Okay, is that all fairly okay? All fairly straightforward? Yeah, no questions, no dramas? Okay, good. Now this one is a little bit more tricky, okay? Because raising something to the power of a half, it's not as easy as just this one, okay? This one you could just observe the pattern that the powers of 6 decrease and the powers of x increase, okay? This one's not as easy as that because you've got that power of a half. In other words, you haven't got a whole number, an integer power, okay? However, we derived a formula last week, okay, which was if you take 1 and you add something, so 1 plus something, and you raise it to the power of n, okay, what was this equal to? Can anybody remember? Yep. N times r, good. N times r plus n times n minus 1 over 2 factorial. You can think of this as over 0 factorial. This is over 1 factorial. This over 2 factorial. Times by r squared. Okay, so you can kind of see the pattern, r to the power of 0, r to the power of 1, r to the power of 2. In fact, this thing comes from thinking about this, isn't it? It's a very specific case of this. Yeah, just do one more term for me. Good. Good, excellent, and so on and so on and so on. So you've noticed the pattern, right? You go 1, then n times n minus 1 over 2 factorial, then n times n minus 1 over, times n minus 2 over 3 factorial. So that's what the coefficients are doing. And then the powers of r are increasing again. And you remember we derived this. We derived this by thinking about this from last week. Okay? Here's my question to you just very briefly before we look at this particular example. What would this be in sigma notation? So you're happy this is a series. Yeah, it's got to be a series because you're adding terms in a sequence together, which means that I should be able to write it using sigma notation. So it basically means a sum. Okay, so generalize it. What would this be equal to? So what would this series here be equal to in sigma notation? Can anybody have a go?
Multiply.
Okay, so let's use a counter. Let's not try and use, so we need to use a counter to correspond to the term which we're looking at. So let's start with k. Okay, that's my counter. Okay, and I'm going to start with k equals 0. Okay, I'm going to start with k equals 0. So yeah, so we're going to have n multiplied by, n minus 1 times n minus 2 times n minus 3 times n minus 4, etc. Okay, right the way up to, if we're looking at the kth term,
K minus 1.
good, n minus k minus 1. Is that okay? Okay, so that's just dealing with this bit up here. So for example, this here would be my fourth term. You happy? 1, 2, 3, fourth term. Okay, so I do n times by n minus 1 times by n minus 2. Yeah, all divided by all divided by k factorial.
R power k.
R to the power of k. Perfect. Does that make sense? Okay. So if I wanted to write this in a nice, neat series notation using sigma notation, so a sum, this is how I would do it. Are you happy with that? Yeah? Okay.